Today we are going to discuss Navi Mill, Mitsubishi Electric's conversational programming software built into the M700 and M70 control platforms. In order to get started, the first thing you need to do on your keyboard is hit the edit screen. This will bring you a submenu for Navi. Before we get started with programming, we need to set up the parameters for the Navi Mill. This area sets up a variety of basic parameters to assist Navi Mill to create a more consistent program. The following parameters are in this area. M0 output turns on M00 at the start of each process. M6 output turns on M6 for a mill when next tool prep is invalid. Next tool prep pre-stages tools for faster change time. M19 orients the spindle. ATC position Z sets the tool change position for the Z axis. Sequence number output adds line numbers to your program. Hole Z clearance R-plane sets the R-plane height of Z axis. Synchronous tap turns on synchronous tapping. Face cut width percentage steps over the face mill and a percentage of the tool diameter. Z clearance sets a safety height for your face mill. XY clearance sets the safety area for your face mill in the XY area. Z approach is a method of movement for Z-axis to move down to your cutting height. All of these parameters are set up according to your program that you're doing, and the main one we need to worry about is maintenance. Maintenance area sets up and allows you to set up the storage macros and your inch or metric settings on your program. So at this time you would set a 1 and hit input. This would bring up the preference submenu key, and at that time you would press preference. Preference is your preference for your macros and your path. It will show you where the program resides, where your programs reside, whether your macros are user macro built or MTB built, your unit, whether you are an inch or metric, your parameters, where your parameters are stored, where your tools are stored, and where your cutting conditions are stored. Once this is set up, go ahead and hit macro entry, and it's going to ask you whether this is okay or not. At this time, you need to press a Y for yes. Macro transporting is completed and is now available to save. So you hit save. This saves all of your settings within their appropriate regions. You then would hit return. The next thing we need to set up is all your tools. Go to the list view, click on tool, and it will bring you up your tool file. Even though, as you see, I only have 4 tools set up, you can set up to a maximum of 200 tools in this area. You need to fill out in the downward columns the following information. T name is the name of your tool. T number is the tool number in the tool change. Length offset is the H number for your tool length compensation. Diameter offset is the D number for your tool in cutter comp. Diameter is the diameter of the tool in inch or in millimeters. Angle is the angle of the tool. Drill angle, such as an end mill, would be 180. Spindle speed is the RPM of the spindle based on 100% cut. Feed rate is the inch per minute of the cut based on 100% cut. Spindle direction, whether it's going counterclockwise, clockwise. And coolant M is the M code used to turn on the coolant. Once you have all of these set up, the next thing you need to do is your cut condition setup. So you go to your list view and type on the cut condition. This will bring up your cut condition area. This setup will allow you to set a material as the base for all of your cutting conditions. Then you can set other materials up as a percentage of your base. This will adjust speeds and feeds of your tools based on material type. Each column is a material type. Fill out the information in each column. The first column should be your base material. You can set other columns to some of your common materials used. For this example, we are going to use stainless steel. The material is stainless steel. Your drill speed, your feed rate speed, your tap speed, your boring speed, your face mill speed, and your end mill or contouring and pocket speeds. The second column we chose was aluminum. So we set 100% for all of our first column for feeds and speeds. In aluminum, we are going to be able to go twice as fast, so that is why 200% is set in there. In this exercise, we will be programming the part shown next. We will be exercising the following operations: using a face mill, using a drill, using a tap, making a circular pocket, and making a contour. Key parts of the Navi mill screen. Number 1 is your list view. Number 2 is your edit window. Number 3 is your window shift menu key. It moves the cursor from either window. The arrow shows which way it will go, either forward or back. Your menu keys, these will change as needed. And your text input window. This is where you will see information you are typing in. And the menu keys will help you move around along with number and letter keys. The first step will be to input a new program. Move the cursor to the Program tab. Press the New on the menu key. Input a program number not listed in the program window. For our example, we will use 1, 2, 3, 4. Then move your cursor to the comment window by using the tab button. And you can type in the comments for the program. For this, we will use Navi test. Press the input button to put the program and comments in the edit window. This will put the program in the list as shown here. Cursor down to the Zero Init Process tab. This will show the basics for the program, such as work coordinates, coolant, M codes. The rest we will leave as standard. If any changes need to be made, press the Modify menu key. Once you have all of your initial processes ready, press the left arrow menu key. Press New menu key. First process for our part is a face mill. You can get to the face process two ways. Use the cursor key to highlight the face procedure, or press the number associated with the procedure. In this case, it would be number 2. Press input. This will bring up the parameters for the face cut procedure. They are face cycle, whether it is a square or a circle, process, whether it is rough or finish, base position, which is the starting point, your width, which is the length of cut for X and Y, surface Z, surface height of final Z height, allowance, amount of stock being removed, finished allowance, extra stock left for finish pass for a rough cut only, number of cuts, how many passes will be made, so to set up the parameters, we start with the base position, and we are starting with X and 1 according to our part, Y and 1, the width, so we want to go 1 inch past our total width, which is a 6 by 6 square, so we will put a 7 in I and a 7 in J. Our surface height, we want to be above the part for safety. We're going to make a 0.1. Our allowance, we're going to start at a 0.3. Our finish allowance, we will set to 0. Number of cuts is going to be a 1. Our starting point, which is down here, will be a 3. The angle will be a 0. And cut direction will be a 1. And hit save. You also need to look at your cut conditions, and you will see that you are registered in tool 1. Your length offset is a 1. Your diameter offset is a 1. The diameter of your tool is 3. Your spindle speed is 1000, and your feed rate is 20 inches a minute. Your spindle direction is clockwise, and your coolant M code is an 8. Go ahead and hit return, and then hit save. If you'd like to check once your data is all in, you can hit checker and hit all continuous, and you will see that your part is done. If you cannot see this, you can scale this by hitting scale, and you can cancel, you can make it standard, you can enlarge, you can reduce, move your target up or down, left or right, and then just hit set. If you want to view in a different avenue, you can choose that. For this, we will choose XY. And then hit all continue, and as you notice, your cut is done. Go ahead and hit reset, and then hit exit. For the second process, we need to go back to our list view, hit new. The second process we are going to do is make a hole. Your screen will look like this. Next, prepare the parameters as such in the diagram below. Go Go ahead and hit hole, hit input. This will bring in your second process parameters. Your tool registration, you need to make a 2 for your drill. The hole cycle, you can choose whether you're going to drill, peck, step, bore, tap, or helix. We're going to choose 1 for drill. The initial Z, again, will be 0.1 to be above the part safely. Your surface Z will be a 0. For your depth, you can choose one of 3 ways to calculate this. For this example, we are going to use the H, and we are going to use 1 inch. And if you notice when I hit input, it sets your nose depth and spot diameter automatically. For our dwell, we're going to use a 2-second dwell. Hit input and hit save. If you notice, no data setting on the pattern screen, which means we need to go to pattern. The pattern is where you want your holes located. For our example, the first hole is going to be 1 inch and 1 inch, 5 inches and 1 inch, 5 inches and 5 inches, 1 inch and 5 inches. And you also need to fill in your return point, whether it is going to be a G98 or a G99. For this, we are going to hit 1 for G98 and input, and then we are going to save. You can go to your checker and do all step, and you will notice that you have now drilled your holes. If the scale is too small, you can scale and enlarge by bringing in your enlargement, and you can also center the screen by moving the center of the dot as close to the corner as possible and hitting set. Again, you can hit your path, and if you notice, you have now cut and drilled your holes. Go ahead and exit out of the checker at this point. Our third process is going to be a tap. Due to the process for drilling and tapping are the same, you can either go in and hit new and start this process over, or you can do a copy. Doing a copy will bring you into your next process with all the parameters from the process that you copied. Go ahead and click on your third process. You need to change your tool from a drill to a tap, and all of your other parameters can remain the same. At this point, go ahead and click Save. To check your process, click Checker, and you can hit all processes, and it will show you everything that you have processed. Go ahead and hit exit. The last process for this part is an internal pocket. Go back with the arrow key, click on new. You want to then click on pocket and hit input. This will bring you to your pocket parameters. Again, we will change the tool registration to 4 for your end mill. we're going to do a rough process. Our ZF to be away from the part again is 0.1. And input. Your Z height allowance, we will make 1.1 because we are going to go around the part. Your finish allowance will be 0. Number of cuts will be 1. Cut type will be 1. A square, your spindle speed is 1000, and feed rate in X and Y is 20 inches a minute. This point you need to go to pattern. You're going to, whether it is a square or a circle, base position of X and Y is 0. Your width, we will make a 6 for I and J, since it is a 6 by 6 circle or square. Your R, we will set, you can either do as a radius or as a chamfer. For this example, we will do a radius. Type in a 1. Your angle is going to be 0. Hit return. Hit save. And then in your checker, you can go to checker mode. Hit reset. Hit all. And you will see your part being drawn out in the checker. You can go ahead and hit exit at this point. To check in your check mode, you can then go to monitor. You can search. Choose your program. 1, 2, 3, 4. Hit input, and you notice that your program is now in memory and your program is listed below. At this point, you can hit check, 2D check, check continue. This will run your program and you can view it in check mode. Go ahead and hit close, and it will bring you back to your monitor page where then you can hit cycle start and you can actually cut your part. This ends our video on Navi Mill Conversational Software Programming by Mitsubishi Electric. Thank you.